thing. All right, we're on this side, the front, the side with the title on it. And I'm scrolling down to the bottom right corner of it. So what we did yesterday was we filled in these tables and we made some graphs. So each column, if you remember, each column of these goes with the motion of one object. So this velocity graph is graphing the same motion as this acceleration graph will, and this displacement graph that we can't see will. And we're going to use this graph to figure out what this graph should look like. So we started by filling in our units up here and filling in our XY chart, time on the x-axis and velocity on the y-axis. So for all of these XY charts, you can go ahead and say 0, 1, 2, 3, 4, except the acceleration ones should say 1, 2, 3, 4. And some of them will go to 5, but I think a lot of them stop at 4. So the velocity at 0 seconds was 0. We don't need to say meters per second because it says it up there. Velocity at 1 second was 5, and at 2 seconds was 10, and at 3 seconds was 15, and at 4 seconds was 20. And we can use that to figure out the acceleration, because you can tell it went from 0 to 5 meters per second in 1 second. And that means it's going 5 meters per second. You can look at the graph the same way as looking at the chart. I prefer to look at the graph. In 1 second, it went up by 5 meters per second. And that's also the slope. So rise at 5 meters per second. The run of 1 second makes 5 meters per second, or 5 meters per second squared. So because in that first second, it changed by 5 meters per second, the acceleration was 5 meters per second squared for the acceleration. And if you look at it, there's a pattern. It goes up by 5 in each second. So each second, it's going up at 5 meters per second, and it doesn't change. So the acceleration is 5 meters per second squared all the way across, and this line stops at 4 seconds. So I can't say anything for 5 seconds, but this will just be a flat line. And all the other graphs like this, all the other graphs on this paper, where you have a velocity graph, it's just all the velocity graphs, once you get them on there, is the acceleration graph will be just the slope of that graph. This is a slope of positive 5. The acceleration will be 5, because the slope here is the same as the acceleration. The slope is 5. The acceleration is 5 meters per second. I hope that helps refresh your memory from yesterday. Are y'all ready to do the top one here, so we can figure out how to do this backwards? Because this is the easy way, in my opinion, to go forwards, is to go from here down. But to go backwards is a little harder. So don't freak out, I'm scrolling up. It's not going to match for a minute. Okay, here we go. That's nice. The second's already lined up. All right, so distance is in meters. And really this is displacement, because the graph shows whether it's positive or negative. I'll go ahead and fill these out. Time is in seconds. Velocity is in meters per second. For all these graphs, we're going to assume that the distance started at 0. And that'll be a good first point for us. Let's go ahead and plot our numbers again. 0, 1, 2, 3, 4. And what was that? 0, 5, 10, 15, 20. All right. So at 0 seconds, it was going 0 meters per second. And at 5 seconds, it was going, at 1 second, it was going 5 meters per second. So it went from 0 to 5 meters per second in there. So let's just say in that So by 1 second is going 5 meters per second. So in between 0 and 1 second, let's say it went 5 meters. It's a little more complicated than that, but we're going to use what we can to make our graph here. So 1 second, it had gone 5 meters. By then, it's going 5 meters per second. And second 2, it's going 10 meters per second. So right now, it's at 5 meters. If in this second, it's going 10 meters per second, then it'll go 10 up from where that 5 is. So it'll have gone 15 by the end of 2 seconds. So 15. And in the third second, it was going 15 meters per second. So if it was at 15 and it goes 15 meters per second now, it would go up to 30. And then the fourth second, it was going 20. So if it's at 30 now, by the fourth second, it'll have gone up to 50. All right. Oh, I'm writing these in the wrong place. At 1, it was at 5. At 0, it was at 0. And then 15, and then 30, and then 50. So, and you can see this line curves. This is a straight line. Whenever you have a straight line of velocity that's not a flat line, your distance graph will curve like that. And we can approximate the curve. We can't do a perfect job with it, but that's how we get our displacement. I might do one more example of those, ones like that. And I will say, just like this velocity graph, the slope was 5, the acceleration ended up being 5. You can do the same thing with this distance graph. It goes up by 5 meters in 1 second, so that's 5 meters per second. Your velocity graph will be a straight line at 5 because it keeps going up by 5 meters per second each time. This is a straight line that has a slope of 5 the whole time. And this velocity graph has a slope of 0. Since it's 5 the whole time, it does not speed up or slow down, so its acceleration is 0 the whole time. So once you get to the acceleration graph, its acceleration will just be a flat line at 0. Make sure you draw it on there that I can, since there's already a line there, make sure you draw it thick enough I can see there's a line. And when you are done with this paper, you can take a picture of it and turn it in. By attaching it to that Google Classroom assignment. I think is what I said on there.
We're doing both sides.
Yes, we're doing both sides, and we've got today and Monday to do this. This isn't due till Monday. But we'll see if we can finish today.